In this video, we're going to look at how the concept of systems thinking can be applied to ice sheets in the polar latitudes. We'll examine how different parts of the system are interconnected, causing global ice sheets to melt. So what is a system? A system is a set of interconnected elements that organise in a way to present certain patterns of behaviour. Systems can be natural, man-made, or both. They are complex, dynamical, and continuously changing. Systems are influenced by what flows into them as well as what flows out. They have stocks, what fills up and drains, and sources, where the inflows come from. We use systems thinking as a way to try and describe a system and its interconnections. A system's interconnections are known as feedback loops and can be positive or negative. Let's look at this in a bit more detail. Positive or reinforcing feedback loops keep a system moving and are self-enhancing, but if left uncontrolled, they can lead a system to collapse. Negative feedback loops, on the other hand, provide balancing feedback to stabilize a system, and despite being labelled negative, these feedback loops are often a good thing. Global ice sheets are in decline, but what do feedback loops and systems have to do with this? Let's take a closer look. Ice sheets work to regulate the Earth's temperature. Their white surfaces reflect radiation from the sun back into the atmosphere, which cools down the planet. This is important to know when looking at how positive feedback loops affect this system. Global warming has led to an increase in our atmospheric temperature. This warmer atmosphere starts to melt the ice, which results in the white surface area decreasing, meaning that instead of radiation from the sun being reflected into the atmosphere, it is absorbed by the sea, causing the temperature of the sea to rise. Warmer sea levels melt more ice. And so this positive feedback loop continues to reinforce itself. This is how it were to look if we drew it out. As you can see, each factor is reinforcing the next, and so the system is spiralling out of control. Now let's look at a negative feedback loop in the system. Do you remember the part where I explained how the surface of ice reflects radiation back into the atmosphere? Well, this is actually a negative feedback loop at work. The more radiation that is reflected into the atmosphere, the cooler the planet becomes and the less ice melts. Unfortunately, this isn't happening at a rate which would counteract the positive feedback loop, which means we're still heading towards an ice sheet tipping point. So what is a tipping point? A tipping point is a critical threshold, and when crossed can lead to large and sometimes irreversible changes. This is a model of a tipping point. As you can see, the system is currently in Basin A. When it moves towards Basin B and subsequently falls into Basin B, that is when a tipping point has been reached. Once this happens, it will be impossible to get the system back into Basin A. Let's look at how this translates to ice sheets. If we look at ice sheets, there are some clear tipping points we should be concerned about. The Greenland ice sheet, Antarctic ice sheets, and Arctic ice sheets are all approaching or have reached tipping points. If and when they melt, sea levels will rise profoundly across the world. So how did we get here? It all started in the 18th century when we underwent the Industrial Revolution. This led to an increase in energy and goods at the same time as the population increased. We've just continued to grow since then, reaching 8 billion earlier this year. Industrialisation and the use of fossil fuels meant greenhouse gases started to get pumped into the atmosphere, leading to a hotter planet. And sadly, we show no signs of slowing down. Put simply, we are in a system in which population continues to increase, therefore so does fossil fuel use, a system which continues to increase global warming and ultimately will lead to the loss of all our sea ice. In this video, we've looked at systems thinking, positive and negative feedback loops, tipping points, and how all of this relates to sea ice sheets. I hope you've enjoyed it.